Dun, 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 dun. All right, right off the bat, I'm going to apologize ahead of time for any technical difficulties we have. We're still trying to work the bugs out of this thing, but it seems to be working fine right now. So welcome to Dissertation Boot Camp, brought to you by the Hawk Tutoring Center down here in San Diego. So let's get to work. So first thing I got to do is switch over to the different PowerPoint. I hope I don't screw this up. So what we're going to do is I'm going to just show you everything I know about GPower, which is a great program. It is a free download from the University of Dusseldorf. It's a German software program, and it's free. Dusseldorf. There's the link. Now, this PowerPoint will be up on Hawk 5 when we're done. So if you can't find a link, just go to the PowerPoint and click on it. It'll take you right there. And there's also there's a couple of free GPower manuals. We have those. I downloaded them into Hawk 5, but you can also get them from the same website that you get the GPower from. One of them is a short one. That's the one I use. There is a longer one. It gets real into detail. You got to have a lot of good statistics background before you start looking at the longer manual. But this is what power is. Power represented by the phi, that's that little Greek letter. It is the relationship between little n, which is your sample size, and that's an omega squared. It looks like a W, which is your effect size. And the one on the bottom is 1 minus omega squared is your error term. So theoretically, power looks like this. It's the relationship between sample size times effect size divided by your within group error. Okay? In a nutshell, when you do your research, there's not a lot you can do about effect size. The calculations will determine your effect size from your data, as the same with within group error. So as you, the researcher, to increase your power, there's not a lot you can do about either one of those at this point in time. There is a couple of shortcuts I'm going to show you later on in a few minutes. But when it comes to power, we should think about sample size. The bigger the sample size, the bigger the power. And you want a minimum of power at least 0.8. So if you run all your tests and you get a power that's less than 0.8, you could be jeopardizing the results of your test. And again, I'm going to show you a few tricks too that would increase your power that don't include sample size. Insufficient power is bad news. Oh, sidebar. You know what? I don't think he downloaded the software. The GPower. I was going to show him how to use GPower. We'll play around with that. I might have to download it, but I don't think I have permissions. Okay. Can you Skype Curtis? All right. Again, insufficient power, bad news. Yeah, ask him if he can come over and download the GPower. He forgot. All right. So there's 3 ways to increase your power. One is the sample size. That's what you can control. Okay? Try to get as many people as you want. It's always a rule of thumb, right? The bigger the sample size, the better. The closer to the population, the more believable your data will be, your calculations will be. Number 2 is increase the effect size. Unfortunately, there's nothing you can do about that. The calculations of your data will increase your effect size or decrease your effect size. But again, it just too much depends on the data. This last one, decrease error, that's your within group variance. That was the denominator of that fraction. There are a few tricks to decreasing error. If you're running an ANOVA, there's a nested design ANOVA that will decrease your error. What that does is it pulls out data that isn't showing any significance anywhere. So how that works is it pulls out the within group variance, which should increase your power. There's another ANOVA called treatment by blocks. And the same thing, what you're doing is you're ejecting data that's not showing any kind of significance whatsoever. So the two that decrease error that I know of are the treatment by blocks ANOVA and the nested design ANOVA. We have both of those examples on the Hawk 2. Okay, Hawk 2 has all the ANOVA stuff on there. Any questions so far? All right, we're going to do a few power analyses with GPower. Ttest, Chisquare test, one-way ANOVA, factorial ANOVA, mixed ANOVA. We're going to do a correlation, multiple regression. Those are most of the tests that you guys will use. Okay, it's about 90% of all the tests you're going to use is the ones I just mentioned there. It takes practice to use this thing, right? It's like playing a piano. Okay, but first thing you do is this is your test family. You got to decide what kind of test you're going to use. I'm just going to walk through every one of them. So exact, once you click the test family, this will be the subcategory for everything under that exact. So you got linear multiple regression, you got proportions. We don't do proportions here. We don't do the generic binomial test. So there's not a lot under exact except for the correlation. Bivariate normal correlation, that's a regular Pearson's correlation, okay? Number 2 is Ftest. What kind of tests use Ftest? That's going to be your ANOVAs and your multiple regressions, because if you didn't realize it, a multiple regression uses the ANOVA to determine if it's a significant regression, plus it uses an ANOVA to make sure the residuals of your model do fit. So again, Ftests, you would do all your ANOVA family and your multiple regression, linear regression, that kind of stuff. Coming up next are your T-tests. So for some reason it has the correlation as point by serial model under T-test. Don't fool that, okay? Don't use point by serial correlations. They're just very, very confusing. But the rest of them are here. So your different means between two dependent, this is your paired T-test, right? Your matched paired T-test. This is probably going to be the one you use the most. Independent T-tests, 2 separate groups. There is a 1 sample T-test. These are about the only, the Wilcoxon test, these are about the only non-parametric tests that GPower does, okay? And then your chi-square test, there's 2 different kinds of chi-square tests, goodness of fit and independence of, what is it, independence of something, sampling independence, something like that, okay? I'm old, so don't judge me. Okay, and then the last one is z-tests, which is basically stuff I've never even heard of. So, okay. So I'm just going to run a couple for you. First one, the most used test that I have seen here is the independent T-test. Okay, so you click the T-test, you go down to independent means, and it asks you, what do you want as an effect size? It will suggest this. It always suggests the median. Hey, how are you? Good. So it always suggests the median effect size. You can change that. Okay? So here's a big trick. If your power is low, you can artificially raise the effect size to large. But some professors will not tolerate that. So just if you're going to do it, make sure they have that you know that you're doing it, okay? But again, the computer will always suggest the medium effect size for every one of these models. Now, there's the critical cutoff alpha. We always use 0.05. You could change that down to 0.01 or 0.001, depending on how strict of a significance level you want. And in the power, we always change this to 0.8. Okay. And this means the ratio of group 1 to group 2. You basically want the same sample size in each of your groups. You hit calculate, and there's your minimum sample size right there. Okay? So in other words, if you're going to run a T-test that's going to generate a power of 0.8 and a medium effect size using Cohen's d of 0.5, you should have about 51 people per group minimum. Any questions? No. Good. Next test. Let's do ANOVA. We do a lot of ANOVAs here. It's a one-way ANOVA with no repeated measures, right? Just one variable. So again, it's going to suggest a medium effect size. We always use the critical alpha 0.05, and this is 0.8. And the different groups, how many groups do you have for an ANOVA? Okay, so normally it's 3, but you can have a lot, right? You can have 10 or 20. But the same thing, you load this site up, you click calculate, and it tells you you should have about 159 people minimum to generate a power 0.8 effect size, a medium effect size. And it gives you the actual power here, okay? Very important. These are a priori calculations. You can do a post hoc calculation. I'm going to show you that here in a few minutes as well. Post hoc calculations use different calculations than the a priori. So, but by convention, we tend to look at the effect size first. We try to pick a fair effect size that we would like to see, and we try to pick a strong power. Anything over 0.8 is acceptable, okay? Remember, whenever you do any test, you look for significance, effect size, and power. The big 3 stooges there. All 3 of those have to be good. So let's say you're going to do a mixed ANOVA. That means you got repeated measures and you have the between group. So that would be, where's that one? Right there, repeated measures, between factors. So that means you got a within group and a between group. That's your mixed ANOVA. Same thing. It gives you a sample medium effect size. Cut the power down to 0.8. The number of groups, number of measurements is how many repeated measures you have. The number of groups is, again, how many groups you have in your between group. Okay? And then this correlation is preset. Don't mess with that. Click calculate, and it gives you the minimum sample size. These graphs up here are very hard to explain, and I'm not sure I can explain them very well, so I'm not going to say that. The critical F line, that tells you that your calculated F should be greater than this line. It should be over here somewhere if there's a significant difference. That's all this graph means, okay? So let's do some multiple regression. Linear regression. This is your basic multiple regression, right? Fixed model R squared from the deviation of 0. And it's going to be an a priori. Again, the effect size. What is considered a medium effect size changes from test to test. So this one's saying that a medium effect size, if you can get 0.15, you're doing good. Remember, effect size is the percent of the variance in the DV that you can explain from your model. So if you can get 15% explanation, you're doing really good. So this one, again, we would cut down to 0.8. And so a multiple regression model, let's say you had 5 predictors. There goes our IT. So you would get a minimum sample size of 92. What else would you like to see? Oh, yeah, Chi-square tests. So remember, Chi-square test is when you're looking for a relationship between 2 categorical variables. In other words, are there more left-handed Republicans where numbers really don't make sense? You do the chi-squared goodness of fit, or the independence of, I forgot the second name of it, but they all work the same. And so the effect size, it gives you a medium effect size, cutoff probability, cut that to 0.8. Degrees of freedom is the number of rows times the number of columns. So let's just say we had a 3 by 2. And that would be 3 by 2 is 6. You minus 1. 3 minus 1 times 2 minus 1, so it's just 2, right? Degrees of freedom for a chi-squared is the number of rows minus 1 times the number of columns minus 1. So you would need a minimum of 108 to generate this kind of power. And any questions? You guys got any tests you want me to run a quick power analysis on? All right. This is going to be a very short presentation. All right, moving on. You could also do post hoc power analysis through this. That means after you've run the data. SPSS will give you a post hoc power analysis as well. So, but if you don't want to go that way, you can go here, post hoc, you would compute your achieved power. Same thing, it gives you the medium effect size, it gives you the cutoff, but this one goes by your sample size. So if your sample size isn't what you were hoping, so let's say you wanted 108 people, but you only managed to get 68, it will tell you what your new calculated power is. So, right, that is less than 0.8. That means that your results are going to be in jeopardy. So again, that is a post hoc power analysis. Very rare, but sometimes some of your professors will want to see one anyway. Here's a new one. It's called sensitivity. What this does is it tries to calculate power, sample size, and effect size all in a quick chi-squared kind of way. I don't want to overly confuse you guys, but we leave the power the same, sample size. This will tell you your chi-squared test statistic has to be greater than 5.99. That's what that says, okay? So, but my best advice is play around with this thing. It's free. Don't cost nothing. And when you're ready, start playing around with it. In fact, if you go to YouTube, there's literally about 300 videos on YouTube that shows you to calculate power for any and every test using GPower. Okay. One side note, there is another way to manually calculate power. There's a video on Hawk 2 that shows you how to manually calculate power, but you have to run the test first. You need things like effect size, degrees of freedom, what the F ratios were, etc., etc. I don't recommend it. It takes forever. And then you got this funky chart at the very back where you have to look up the power, and it's got all these crazy things that you can barely read. And so I do not recommend doing power by hand, but I do recommend using GPower. I see it all the time now. It's been very, very popular in the last 10 years. Most faculty do not have a problem with it. It is very accurate. It tends to be a little bit high sometimes, but I would say that's fine. Questions, comments? It's called GPower. And there's the link is on here. It's on a PowerPoint. It's going to be on Hawk 5. Again, all of this stuff, the PowerPoint, we're going to turn this into a video. It will all be on Hawk 5. You know how to get to the Moodle. Just type in Hawk, go down to Hawk 5, self-enroll if you're not in there. So everything's there. The ones that we did from Qualtrics are there. The SPSS stuff is there. Everything is in Hawk 5.
So that's it for the power analysis on the Dissertation Bootcamp. MGZ, out.